Hello, welcome to the Science for Policy podcast. My name's Toby, and today I'm joined by Professor Andrea Emilio Rizzoli and Manuel Kugler. Professor Rizzoli is the director of the Dalle Molle Institute for the Study of Artificial Intelligence at the University of Applied Sciences and Arts in southern Switzerland. He has a background in control engineering, and he specialises in simulating dynamic systems and in applying AI to environmental problems. And he most recently co-chaired a working group of experts within SAPEA, that's part of the scientific advice mechanism advising the European Commission on their request on how artificial intelligence is and should be incorporated into scientific research. And due disclosure, of course, I work for the scientific advice mechanism and they publish this podcast, but we're not going to spend too much time on that particular piece of work in our conversation anyway, I hope. And Manuel Kugler is the Data and AI Program Manager at the Swiss Academy of Engineering Sciences. He was trained in material science and he worked previously as a technical specialist and a process engineer for a high-tech manufacturing company. So, Manuel and Andrea, welcome to the podcast.
Thank you, Toby.
Hi, Toby.
Hello.
Thanks for having us.
So I'm looking forward very much to this conversation. I know I'm not the first to this party by any means. I think pretty much every podcast I listen to and every event I go to and a lot of what I'm reading at the moment in the media is talking about artificial intelligence. And there's a lot of talk about the impact of AI on society, of course, and also about what kind of policies we might need, how we should be thinking about regulating AI, and so on. But the reason we haven't covered it until now on this podcast is that I've struggled a little bit to understand what we can already say about the impact of artificial intelligence on the world of science advice and perhaps science and research more generally. There seem to be plenty of experts on AI kicking around at the moment, but not many who have experienced the science policy interface. But you both do have at least some experience in that area. So this is all just to say in advance, thanks for agreeing to come on the show. And I hope we can have a suitably wide-ranging conversation.
Oh, thank you, Toby. Yes, I've been involved in this great effort. It was the evidence review report on the successful and timely uptake of AI in research that was requested by the European Commission. And that introduced me to this fantastic world of science and policy. And actually, in my role as a director of an AI institute, I do have very often to confront myself with these questions and issues. But I do not see myself as a real expert. I think that I'm learning by doing in that sense. And, this is excusatio non petita accusatio manifesta. But actually, we have to acknowledge that we are all a bit learning, talking and reasoning about the impact of AI on science, on our society, and how we can work on policies to understand and to better steer the impact that AI might have in the future.
Yeah, I would agree to that. And I think there's probably not that many experts in that field, really. And I think since it's an ongoing development and the topic is still evolving, so I think it's fair to say that we're all learning on the way.
Mm-hmm. I think it's important that the scientists actually get to know how to talk to the policymakers and vice versa. Maybe in the environmental domain, this has been the common practice for the past years, even though if we look at the type of communication that the researchers on climate change have tried to push through to policymakers during the past, I would say, 70 years, and what we have achieved so far, well, the situation is pretty bleak and dramatically unsatisfactory, I would say. I think policymakers are aware, the general public is aware, but there is no much action towards really fighting climate change. I do not think that AI is posing a major threat to our existence as climate change is, but I still think that it is important to reason on the impact that it will have on the society and on our jobs and in the future.
Good. Well, I hear what you're saying. And I'm very happy to take this conversation as just that, something exploratory where we reason together rather than something more didactic. Having said that, I do want to start by asking you to be at least a little didactic, because I think it would be really useful to get a high level view first, and then we can zoom in whenever we need to. So let's imagine perhaps that I've just woken up from, I don't know, a 10-year hibernation. And I'm looking around me and thinking, okay, the world's changed a bit. No flying cars yet, but it seems like we do at least have the beginning of sentient computers. So that's not entirely disappointing, I guess. Could you outline the current situation in the development of AI as it might strike me in that situation? What's happened recently? Where are we at in society as a whole?
Yeah, that's an interesting perspective, Toby, about this fictional situation in which you wake up after 10 years. And definitely, maybe even 10 years ago, you could have glimpsed some of the promises that AI was heralding at the moment, like the ability to process natural language, or at least not really to understand, but at least to make sense and to understand voice commands that we could give to devices, to smart devices, the ability to process and to understand what images we're representing. But now generative AI has taken the lead, and now you can also not only process and understand the content, but also to generate new content. And this is clearly something unprecedented in terms of what we've been used to. And this would have been a great surprise for Toby waking up after this 10 years sleep. But where is it going this in the future? It is not really certain. Some people might try to overemphasize this, what is happening now, trying to attribute the capabilities that these algorithms don't have, like the fact that these computers seem to be able to think, but they are not really conscious as we are. And the type of intelligence that they are showing is a totally different intelligence from the one that we have. They are not able to explain things very well. They still have these hallucinations that we are now used to call them. And so the situation is clearly dynamic, is evolving very rapidly, but maybe there is a little bit of hype around all of this.
Yeah, maybe if I may add, I think looking back at the last 10 years, there was a lot of development accompanied by different headlines announcing the major milestones in terms of games, AlphaGo and so on, that came with additional computing power and additional availability of data. And I think that's always seemed to be like a major milestone and a new development that was achieved now. But I think that development was quite continuous also in terms of large language models and so on. I think it was continuously evolving and usually getting better. Now we're at the state that we have services available to both experts, specialized systems for science and industry, but also publicly available tools and software gadgets also to the public. This democratization of the technology, that it's available to everyone and can be used either by interfaces and at the same time also everybody who is interested in learning this technology and further developing it according to their own needs. If you invest enough time and money, then you have the capability to do so.
I think that what Manuel says is particularly right when about experimentation. I mean, all of this is very experimental, and I think that these companies that are offering these large language models to the general public, they took a gamble in opening them up, and they didn't even know what the reaction would have been. And I think they are still learning, and we're all learning about the interaction with these systems and with these models. This has been quite a risky thing to do, and I'm not totally sure I would have done the same thing had I been in that place, but clearly they are right to make these experiments, given the success that these type of things are having, also commercial success, we can say.
Yeah, I mean, to those of us on the outside, it does kind of seem like it's suddenly just gone boom in the last, 18 months. But you're describing a more continuous improvement, I think. So if I understand you rightly, this impression we have of the sudden leap forward comes more from it being available widely and with a non-technical interface rather than a sudden unexpected development in the research itself.
Yeah, I think so. I mean, it's called GPT-3 and then GPT-4 because there was GPT-1 and GPT-2 before. So the progress has been quite smooth, if you want, in the capabilities of these tools. And also the image generation came before text generation, and there was a clear line of research going in that direction. So what was really amazing was the fact that being able to train these models with longer and longer sequences of text improves their capabilities. And this was totally counterintuitive to what people would have expected, because usually when you threw more data into a specific model, you get overparameterization that is able to fit to a particular specific situation very well, but is not able to generalize. While on the other side, these models are able to generalize quite well the more data you put into that. And for the moment, there has been no explanation that has been provided. It is totally satisfactory about this type of behavior. So research on these models is still going on very, very strongly. And there are many, many unanswered questions on the table.
Yeah. I wonder about this question of the rate of progress now and in the future, though, because if we're now in a kind of experimental phase, as you describe, so we're getting these big leaps forward, which are powered by things like increasing computing power and increasing public attention and accessibility and so on. And we get maybe, as you say, some hype, also some overly big claims. I think it's possible to look at this situation, look at how fast things are all pushing forward now, looking at the pace of change, and extrapolate that to the future, which then looks extremely dramatic, right? You get this prediction of things accelerating faster and faster, or at least at the same very fast speed, and causing huge changes to society, very fundamental changes. And I wonder whether this is perhaps, I wonder whether you think this is realistic, or whether we're being misled by extrapolating, as it were, from a very steep gradient early on the development curve. Mm-hmm. And maybe we should expect that curve to kind of flatten off a bit as the technology becomes more mature and the early gains become harder and harder to replicate.
Yeah, well, okay. This is a nice question, because making prediction is really hard. Here at TIZIA, we had as a PhD student Shane Legg, who went on to found DeepMind and is researching on artificial general intelligence. And he recently was here in Lugano talking about his past career and what he expects from the future. And he said that he wrote about 10 years ago that in 2028 we would have had artificial general intelligence, which we might be approaching, but it depends on what we define by artificial general intelligence. And he also mentioned the fact that this type of intelligence will be an alien intelligence, so something different from our intelligence. And this was, I think, a very, very reasonable remark. Yeah, can we extrapolate from this growth? Well, I don't know. Personally, I think that all growth is limited. I mean, we are coming to a saturation at a certain point. Then, coming from an environmental perspective, you know, the shape of growth that is first exponential and then it becomes saturates to carrying capacity. So you arrive to the carrying capacity of the current technology, then you might actually increase this carrying capacity by a jump. And we've seen this in a number of technologies in the past, starting from Industrial Revolution. And I think that we can make some extrapolation on what has happened in the past, that you arrive to a certain point where these technologies are being used widely, they improve, but they arrive to a sort of a plateau, then something new comes out. But this is a bit contrary to natura non facit saltus, as Leibniz said, if I am not wrong. But I think that there are small leaps, small quantum leaps that we can expect in the future, but I do not know when. So these quantum leaps might be not evenly distributed in time, might not be accelerating as some theoretical researcher about the singularity are discussing, but definitely we will see a growth. We will see some different stages of this growth, but don't ask me when and where.
Yeah, as Andrea mentioned, predictions about the futures are particularly difficult. But I agree that it will be or I would expect at least a kind of a plateau as well in terms of the quality of the systems. I think it will continue to improve, as we've seen recently as well with these chatbots and so on. But I think it will never reach a perfect system, so to say. If you think that it will answer everything right or everything the way you want it, I think also regarding translations and so on, I think these systems and services are better every day. But I think it will be always in the end the human operator who uses these systems to decide to what extent it is what they want or they expect. So I think it will continue to improve, but still I don't believe yet in artificial general intelligence.
Mm-hmm. Good. Okay, thank you. I want to zoom in now on one domain, the domain of science and research. Andrea, you mentioned already you were involved with, in fact, you co-chaired a piece of science advice on exactly this topic for the European Commission. So I think you're probably as well placed as anyone to talk about this. So please talk about it. What's going on in the domain of science and research with respect to AI, and what can we expect also in the foreseeable future?
Yeah, we did this very interesting work of collecting evidence on how AI is impacting the scientific research environment, and the evidence is, it's in some parts, in some specific disciplines, quite convincing. In some other parts, it is still to be collected, to be produced. Definitely, let's say that the so-called narrow AI, that is machine learning applied to specific problems where we process a huge quantity of data with techniques such as deep reinforcement learning, has been making great progress. For instance, in the very known application of protein folding. And so there are a number of similar applications where you can see the impact that AI is doing in advancing scientific research, but also a manifold increase in the productivity of scientists. While on the other side, this generative AI impact is a bit more debatable, if you want, because the fact that in some cases the explanations that are provided by these tools are unclear, the line of reasoning that you have to trace back is not totally clear, it is very difficult to apply the scientific method to some of the results that can be produced using this type of tools. And in some cases, this is also being a bit worrying because an abuse of these tools might lead some researchers to cut some corners short, producing some summarization of text for this. These tools are very good, but who guarantees that the research, the summarization, has considered all the different viewpoints, all the different perspectives on a particular problem? And for this reason, we are in a very critical stage where we have to be very attentive and very careful about the use that is made of AI in scientific research. Great potential, but also great risks. And I think that this comes out of the evidence review report and also the scientific advice that the European Commission has received from the chief scientific advisors.
Yeah, I think AI in science is playing a major role. I think it's a tool to be applied in different ways. I think the obvious thing is to analyze the data that you're collecting. What Andrea also touched is to use it as, on the one hand, as a tool for repetitive tasks, to writing up reports and publications and so on. But also, I think it is more and more used to create new hypotheses, to explore what is possible, for example, or exploring new materials, new combinations of elements, and so on. I think there is still a lot of potential. I think it's already addressed, but I think there is still a lot to be expected. And I think this then also these challenges that go in hand, that also Andrea mentioned, I think this is calling also for guidelines in terms of how to deal with it, what is okay to use when, and how is quality assured. I think there is still a bit of a vacuum there.
I have two competing puzzlements here, which is a strange sensation. I'm not sure which of two things I should be most puzzled about. Mm-hmm. On the one hand, it seems like you're pointing to these applications where AI is, or at least can be, extremely useful. Things like data analysis when you've got huge quantities of data, or tasks that are extremely computationally intensive, where the parameters of the task are well understood, but the job of actually doing it is very arduous. So this is like the protein folding example, I think, right? Where an AI can do overnight something that used to take a PhD student their entire PhD. And it seems like not only specialist AIs, but also the general purpose generative AIs are also already quite good at this. Or if they're not good yet, you can see the potentials there for them to get very good at it soon. And this idea of being able to engage with an AI via a non-technical interface, like just typing a natural language prompt or speaking one. And by doing that, be able to apply all this power to the slog work of doing scientific research, that's very exciting. But then here's my first puzzlement. My understanding about basically how generative AI works, and my concern about it being relied on too heavily in science, is that fundamentally it fundamentally just remixes and represents stuff we already know. Which I guess is not to say it can't make progress on hard tasks. I mean, clearly it can. It can even make new discoveries in certain domains. But it does seem to place a constraint on how much we can expect from it in terms of creative leaps forward, lateral thinking, these flashes of new insights that are also supposed to be a big part of science, of scientific discovery. So that's one thing I'm unsure about, like how to stop the role of AI expanding so that it blocks off some elements of the human creative process that science relies on. And then there's my second worry, which is completely the opposite of that, because it seems to me when you actually use these general purpose AIs like ChatGPT or whatever, I mean, I've played around with them a little bit, what you notice is that they're actually not great at the factual analytical stuff. I mean, they're light years ahead of what we thought they would be, but they still hallucinate and miss details and give inconsistent answers and can't do basic maths, as we've all seen. But what they seem to be really breathtakingly good at, where the magic is most obvious, is in these creative tasks. If I ask the AI to write me a limerick, it can do it as well as any human I know. If I ask it to write me a dialogue on a particular topic with certain bizarre constraints, like, I don't know, write me a dialogue between two pirates about booking a hotel room without using the letter A and including punning references to 6 different underwater mammals, I don't know. It can do that kind of stuff in a way that really takes your breath away. And these things seem to be way more good at the crazy creative stuff, like really off-the-wall stuff, than they are at being accurate and methodical. So my question is, what should I be worried about here? Should I be worried about like stultifying creativity in science by relying on AI? Or are they in fact really good at creative stuff and we should be feeling threatened by how fast they're kind of moving in on our human turf?
Well, good question, because it means, what do we mean by creativity and innovation? I think that as human beings, we also build on our past experiences, on what we already know. And sometimes you get that spark and creates a new way of looking at things that we already knew. And maybe you have a great intuition, a great invention. And these tools might be able to of doing this, yes, but the point is that they lack the consciousness and ability to explain why they've done something. So just make a simple example. A colleague of mine was trying to understand how we could do a totally decentralized regulation of renewable energy generation at the home scale. He saw the correlation between a voltage drop and consumption at home. And I mean, this is totally intuitive, the fact that if the voltage drops, then this means that there is excessive power consumption. And so this is something that any algorithm could discover. But then he had the intuition of using this to design an algorithm to react in managing the future consumption of energy by appliances that we can steer, like switching off and on the washing machine and this type of things. So I'm wondering whether an AI algorithm can do that. Probably yes, but can it explain it literally? Probably. This is still debatable.
And this is a problem in science because we need to be able to understand, to see the working, you think?
Yeah, I think that the causal explanation is still the most important part, together with the scientific method of the repeatability of experiments. And very often the answers that you get from these tools is different from the time to time. There is no consistency. You rerun the same questions, the same things at a different time, and you get different answers. And so we do not also know the type of data that are being used for training. Most of these models are quite obscure. All of these things will be solved in the future when more public and open research will be done on this type of tools. For the moment, public and open scientific research on this type of models is trailing, but I think sooner or later we are catching up, and also commercial companies will realize that they have to build the trust that is needed to be able to use these tools for serious things rather than writing limericks or doing other fancy stuff that is funny for sure. But I've seen that the majority of attempts of using these things in real-world environments, they have been plagued by a number of problems, like the fact that the information provided maybe by chatbots is not totally reliable and these type of things. You might have that also in human-operated call centers, for instance. But then we open up the issue of responsibility. Who is responsible for that? And this is, again, something that applies to any type of automation.
Yeah, I think it's a really interesting question, and it covers a lot of aspects. I think that are not straightforward. I think it's, on the one hand, it will always depend on the training data, at least for foundation models that are being trained on large amounts of data. And there, I think usually the data that you feed into these systems will kind of define the playing field that you have. So kind of also set some boundaries, and depending on this data, the outcomes will be some combination of the existing data. And so I think in the end, it will be up to the humans to decide whether or not something is creative, maybe in terms of arts or masterpieces and so on. So if for example, an AI creates the most beautiful painting in the world, so it's still the persons who decide on that, who will judge on whether that is creative or not. And I think it depends how those systems are set up, how they are on the one hand trained, but also what their limitations are in terms of whether or not something maybe also outside of the training data is available, is allowed, and to what extent kind of not only statistics within this data, but also beyond, some kind of random numbers, random outcomes are allowed. So then it will also open up the room for potential additional errors, but also potential new solutions that maybe haven't been thought of.
Yeah, well, if we come to art, I'm not an art expert, but I think that beauty lies in the eye of the beholder. So it is the fact that this type of AI-generated art will be anyway prompted by someone. So there will be a sort of an artist in charge. If we think at the work of Catalan, for instance, he's an artist that actually doesn't do anything with his hands. He has a concept and asks some people to create this sculpture, like Hitler kneeling in front of, I don't remember actually, that was or either the Pope or something like that, a weird conceptual piece of art that is created by very skilled artists, other teams of artists. So if a person like Catalan uses an AI instead of a human, it makes no difference at all. What is maybe more worrying is the impact of this type of tools on a category of people that create, well, not really art, but artistic representation like graphics and this type of things. This type of industry will be definitely affected by this type of tools because the productivity will be increased. An increase in productivity means that some jobs will be lost. So this is totally different from what we are talking today about the impact on science. But I do not think that the impact on the number of scientists will be as dramatic as in other professions. But this is also a side of the problem of the application of this type of tools in the society.
An interesting aspect is that just the amount of the creator the work that goes into that. It's very much reduced with AI systems and these new tools. So a prompt is enough to kind of create something big already. And just because of all this available data that's already in there, and that just reduces what you kind of have to provide to create something. It's still the one who writes the prompt who kind of gets the benefit of it. But I agree that the productivity will massively increase, but the quality is still up to the creator to decide to what extent it's good or not.
So in this big constellation of what AI can do now and what we think it might be able to do in the future, and how that interacts with our society and so on, what do you think are the big decisions that policymakers face right now with regard to AI? And also, what information do they need? What scientific evidence do they need to be able to make those decisions?
Yeah, I think the main question that is posed here is how to materialize the huge potential that comes with the new technologies of AI and others, while mitigating their risks and therefore still enable innovation with AI, but also provide boundaries within which AI can be applied in a responsible manner, including topics like reliability, explainability, and trustworthiness. So I think policymakers and regulations in general, they focus how to prevent misuse of technologies and protect the weak from undesired outcomes and the impact of these systems. And yeah, since AI is really implemented everywhere, that's very a difficult task to find a balanced strategy here.
Mm-hmm. Yeah, well, on one side, the policymaker shouldn't worry about regulating research too much, but what they should definitely be informed about is what is the real current potential of these tools, what are the advantages and what are the shortcomings, so that they can help. Well, the scientific community is not totally separate from the society, and therefore the scientific community is responsible for the results that it is publishing. And so I think that the scientists should be totally transparent about how AI is being used in some of their research, and they should provide, again, a way for science to be reproducible and verifiable. So for me, this is very, very important. And if you want, this is something that we are missing at the moment, because these tools are not scientific results, they are more products. So they are sold by companies, and we have little opportunities to look under the hood of how these things really work. And the problem is that then when you use this type of things into scientific research, then you're bringing the opacity into your own work.
Yeah, I think it's usually depends a bit on whether you're using commercial tools or open access tools that are not clear how they are developed, or whether it's kind of a scientific tool that was developed for a certain application. In general, I agree with Andrea that you shouldn't regulate research too much. But here again, I think you have to differentiate between basic research and applied research. And it's typically wiser to focus on real-world problems rather than different potential scenarios, and then implement rules and guidelines how to deal with these hypothetical cases. The main thing that they need to understand is, as already Andrea said, problems that are associated with, I think, also mainly the further development of the technology and the actual problems that arise with the implementation.
Right, so you frame this as the need to realize potential while mitigating risks. And that's interesting because, I guess that's a fairly uncontroversial pair of priorities. But I think if you look at the public discourse at the moment, and indeed if you look at things like the EU's AI Act and other policy moves being made around the world, the focus seems to be very much on the second half of that pair, on the risks, like you said, preventing misuse, protecting people from undesirable outcomes, and so on. I'm interested in asking you then about the first part, this idea of realizing potential. I mean, it feels a bit to me like the potential is realizing itself without us having to do very much. What's the ask from policy there? Do we need them to grease the wheel somehow, or is it about equity, or is it about keeping up with the Joneses? Making sure that we in our country or our part of the world don't fall behind others.
I think to some extent it will just happen. I think everything that will that kind of gives a benefit to the users, or be it society or scientists, I think it will be used if it is a commercial service. But I think nevertheless it would be important to also further foster the development of AI, not only rely on the big techs providing their systems more or less transparently how they are trained and developed. I think it's important here also to kind of look at practical use cases on which the technology should be applied. Touching on again environmental problems, climate change, I think there is huge potential, and there you could do more, I think, still today. Yeah, also not, at least in Switzerland, that's fostering technological development is not very common. Yeah, I think the EU is investing a lot. I think there are programs in place, and Switzerland needs to find their own way to some extent.
Yeah.
Okay, that's interesting. Andrea, do you agree? How much of the role of policymakers is to protect and regulate, and how much is to focus development at the right strategic priorities, and how much is to keep us competitive, keep Europe, let's say, competitive?
Yeah, for me, the role of a policymaker is very important, because it has to understand the questions that are on the table, the issues that are on the table, to promote and to make some key strategic decisions for the future. Well, in Switzerland, there is a lot of emphasis on direct democracy, so everything is subject to initiatives and to referendums. And definitely there could be referendums and initiatives about the role of Switzerland in European research and this type of things. But I think that policymakers must make an effort to make the grounds for some decisions very explicit and clear to the people that can then support these decisions. So it's important to create an awareness in the people of the fact that we are at a sort of a turning point on some key issues. And I still put the climate crisis before AI. And so this is the major worry I have. Then AI can be an instrument to solve some of these problems. But I think that we have to work jointly with our international partners on these two topics. You cannot solve climate change on your own. You cannot do AI research at a competitive level on your own.
Yeah, I agree. I think Andrea mentioned already Copernicus. I think these initiatives and activities are crucial and are important to support, because they also then open up the space for further development and to actually realize the potential of AI to solve bigger problems. And I think that's one area where policymakers should focus on, how to actually make it possible to realize the potential of AI. And availability and accessibility to high quality data is one important issue. And another one, access to computing powers. I think there is a lot of initiatives ongoing, and it's important to support.
I mean, you, Manuel, you in particular, but I think both of you to some extent, have been thinking about science for policy on this topic in Switzerland. So as a kind of case study, what's it like advising policymakers on AI in Switzerland? How does it feel doing that kind of work? Are they engaged? Do they have the evidence they need? Things like that.
Yeah. Right, where to start? I think SATW started their focus topic on artificial intelligence a few years ago.
SATW is the academy, right? Technical
Swiss Academy of Engineering Science. Yes,
yeah,
sorry. And I think already there, the readiness or willingness to kind of get inputs by the experts, because they are aware, I think, that they need the expert opinions and the knowledge of the experts, because they don't have that in-house to decide. And I think the willingness to reach out and learn or get the inputs from the field I think that is in place in Switzerland very much. I think there is a culture of exchange and the openness for a discourse as well. One activity that we initiated together with partners as well, focusing on research, we wanted to get an overview on what is happening at different Swiss institutions. And together with partners, then we launched this SIROP initiative, so Swiss AI Research Overview Platform, which on the one hand was the goal to get an overview what different aspects are covered in Switzerland, not only pure development, but also applied, as well as all the LC questions related with AI. And there we wanted, on the one hand, get this overview, but also foster the exchange within the academic community. And now we're continuously expanding the network because the main goal of SIROP is to kind of foster collaboration across different stakeholders. And this involves also the federal administration, as well as solution providers and SMEs and other corporates.
So is SIROP primarily like an internal-facing network for researchers, or is it also meant to be an access point for policymakers who want to understand research and evidence?
I think what we try with SIROP as well is to kind of condense a bit and connect everybody, the different stakeholders. And so we started with the academic community because you have to start somewhere. It's difficult to involve everybody at once. And so what we're aiming now is to continuously expand the network. So we have also CNI as a partner. Meanwhile, they joined. So CNI is the competence network on AI at the federal administration level. We're in constant exchange with those. And now, as a next step, we would also like to involve solution providers and companies to join the conversation and therefore also foster collaboration between the different actors, but also come up with recommendations for policy if necessary. Of course, only if there is a need, and we also need to put recommendations in place.
Yeah. Okay. So we've talked a lot about AI in general and about how AI is affecting science and research and how researchers are engaging with it. I want to zoom in again now, though, and look specifically at the area of science for policy, so science advice. Do you have any insights into how all these changes we've been talking about will, or maybe are already, affecting the process by which policymakers get access to evidence, to science advice? Or indeed, how the job of a science advisor, whatever that means, might change in the future because of all this?
Mm-hmm. I think that there will be an increase in productivity and effectiveness, definitely, because these AI tools will help the science advisors to look into the evidence that is available, to review it, and there will be an interesting complement in making summaries, in synthesizing reports, in producing and doing all the hard background work that we've seen that is done when preparing an evidence review report. So, but I don't think that AI will be a substitute for the interaction between people reasoning about a given topic. Clearly, we'll be reasoning on some of the suggestions and some of the things that have been prompted by AI that might be able to pick up some trends, some things that we would not see otherwise. But again, as in many other real-world applications, I will see there will be a strict collaboration between the human and the AI. So I do not think that this will make science advisors obsolete. Actually, AI will be an enabling tool, like we had many others in the past, like indexed databases of publications, electronic publishing, and so on. So AI will help us in making sense out of this, but we will still need the human component to prepare, to debate, to analyze, to review, and to talk to people.
Yeah, and unfortunately, have to agree with Andrea. I think we're quite on the same line here. So it's I don't, in my opinion, it won't change policy advice much, not very dramatically. I think for the foreseeable future, it will still rely on the hard facts and accordingly to frequent exchange with the experts from the different fields. And so therefore, I see it as well, AI as a tool potentially as to collect information, to access the ever increasing amounts of data, and then it will still depend on the human advisors to make sense out of that, to draw the right conclusions, which can be kind of pre-analyzed, pre-condensed by AI, but in the end, it's going to be
maybe
the human.
If I can project myself a little bit in the future, when we will have better tools that are able to provide better causal explanation of some fundamental mechanism, they will be able to explore various scenarios, and so the layout of possible and potential scenarios will be facilitated by these type of tools. And so the humans will be able to reason about these potential scenarios that have been co-generated by AI. But this requires something that is not at the moment yet present in the current generation of AI tools.
Yeah, and what I think is still and is going to be crucial is to provide the right vessels to foster this exchange and knowledge transfer as well. And therefore, there I see SIROP as a potential one, next to others, of course, that are in place.
Good. Thank you for that. Our time is nearly up, but I do want to take advantage of your goodwill for just a couple more minutes. And this is really my own self-indulgence rather than anything on topic. Because Andrea, you mentioned a kind of offhand a couple of times at the start of our conversation, of course, these generative AIs are not conscious. And I'm not necessarily disagreeing with you, but I wonder why you say that. Why are you so confident about that? Is that like a factual claim or something more philosophical? I mean, I think it's pretty clear that whatever internal architecture these AIs have, it's really very different from ours, from our brains. Well, fine. But that in itself doesn't necessarily rule out consciousness, does it? I mean, I guess what I'm asking is, what's missing or different about these AIs that they would need to have to be conscious?
No, well, again, I'm no philosopher. I'm no political scientist. And so I'm not many things. But here, my feeling is that if they are conscious, well, they hide it very well. Because, I mean, you're talking for a long time with these tools, and sometimes they start diverging in a way that might make you think that if you're talking to a human, this person has some serious psychological problems. And so this is why I'm inclined to think that they have no consciousness. And also the algorithms on which they are based, that are basically statistical correlation, make me think, oh, come on. I mean, we cannot be that simple, I hope. So personally, I cannot tell you what is the consciousness level of a human, of a dog, of a cat, of a crab, of a cockroach. So I'm not able to distinguish between the different states of consciousness of all these living beings. So it's a definitely hard question. And again, I think that if you have another podcast with some philosophers, then you could have a very interesting discussion about this. But there are no hard facts, but there are some elements of evidence that make me think that they are not conscious for the moment. Maybe consciousness will emerge, but for the moment, in my experience, they are not.
Yeah, for me, it depends on the how you define consciousness, right? So I'm also not expert in the field, so I'm not sure what is the current understanding of it. But for me, it requires being immersed into the world and kind of have your personal point of view of the world. So in that sense, I think an AI system has somehow its own world, very limited to the data it is exposed to or it is trained by. So there, within that limited world, I think depending on how you define consciousness, again, it is maybe conscious about its small world, but it has no view of the whole impact on the external world because it doesn't know what humans are, what the world is, and so on. I think to teach that to an AI system and to kind of give it feelings and emotions and creativity and everything like that, I think that's beyond what we are at right now, and I doubt that we're ever going to get there. But depending on how you define it, you may think of being conscious about its own little world and that is exposed to.
Well, so many fascinating questions to explore. I'm very sorry we can only scratch the surface of a few of them. But thank you both very much indeed for this conversation. It's been enlightening, and on balance, I think it's been more reassuring than scary, which is not a foregone conclusion these days when you hear people talk about AI. So, Manuel Kugler and Andrea Rizzoli, thank you very much indeed.
Thank you, Toby.
Thank you.
Thank you for having us here today.
Thanks for the invitation.
The Science for Policy podcast is created by the Scientific Advice Mechanism to the European Commission. It's produced and presented by Toby Wardman, with additional editing by Nina Skorczak. The Scientific Advice Mechanism provides evidence-based expertise and policy recommendations to inform policymaking in the European Commission. This podcast is funded by the EU via the SAPEA Consortium. Our theme music is composed by Carlo Alfredo Piatti and performed by Elisaveta Shushenko.